Good afternoon and welcome to Design Master Training. My name is David Robison. Today we are going to be looking at some circuiting options in Design Master Electrical. If you are attending the training live, you can ask questions in the chat box. If you're watching the recording of the training, you can call or email your questions. Our phone number is 866-516-9497 and our email address is support@designmaster.biz. So let's get started taking a look at the options for circuiting and wire sizing and load types. So we run the options command. I have it on the toolbar here just to make it a little simpler for me while I'm doing this. You can also access it on the ribbon, on the DME customization ribbon. You can get to your options here. We have it separated for the project, and then also the standards is over here on that section. It's also available on the pull-down menu under customization, options. You can edit the project and the standards. Both of those require a couple more clicks, so just for the ease of the presentation today, I pulled it out to a separate toolbar. So I'm going to run this options command. We are looking at the third section, scrolling down, the circuits, load types, and wire sizes. The first option there is the unused circuit description, and this is what shows up on your panel schedules or other distribution equipment schedule when you don't have anything connected yet. And we have four options. Basically, there's two choices, whether you say space or spare for the description, and then the size of the breaker. If we list a breaker size or we list no breaker size. Actually, at the request of a customer, we added a fifth. There's also the option to have a dash with no breaker listed. So rather than saying space or spare, it's just a dash. So right now it's set to space with breaker size listed. If we go take a look at a panel schedule, you end up with something like this. So we have our breaker sizes listed and our circuit descriptions are all set to space. If I change that in the options, I'm going to change it to say spare with no breaker size listed, which is probably the most nonsensical. I don't know that you would ever actually do that, because if you have a spare breaker, there's probably an actual breaker size in there. But just to demonstrate how it works, I'll change that, click OK. And then if we update this panel schedule, you'll see that it's going to change. It changed space to spare, and we are not listing any breaker sizes. And the newest option that we just added is the dash with no breaker size. I'll go ahead and select that just to see one other choice. Update the panel schedule again. The breaker size is going to not be listed, and then the description will just have a dash. So you have options there as to how our default uncircuited circuits show up. The next option is the default circuit layer system. So the circuit layer system is used for the home runs and the loops on the circuit. On the one-line diagram, it's also used for the feeder line. So you have a choice for what that layer system is going to be. The default is the same as the distribution equipment. You can also force it to be new or existing. So if it's the same as distribution equipment, if you have an existing panel, you'll have existing circuits. A new panel will have new circuits by default. So let's take a look at how that ends up working out. We'll go over here. I'm going to circuit a new section here just so we have something to work on that's simpler than those other receptacles there. I'm going to take L1, take this circuit 1, put these devices on it. And so for this circuit, we have the layer system listed, and it's currently set to default, meaning it's going to use what that option is set to, and that default is same as distribution equipment. So it's tracking back. It says, okay, it's the default, it's the distribution equipment, it's on L1. L1 is a panel that's a new panel, so the circuits are going to be new. So if we draw the home run and loops, we get new home runs and loops. If we change that panel, say we go back to panel and we go to L1, and we change it from new to existing, and then we redraw that home run, it'll change it from a new to an existing layer. The coordinate drawing database would pick that up as well if you do a bunch of changes. So if you do make those changes, you can't have to kick it and have it update that for you. We can also go into options and change it so that rather than being the same, we could force it for the default to always be new or always be existing. So I'll change it to new. So it's an existing panel, but now the circuit is set to new. So if I draw those home run and loops again, it will draw them on the new layer. And for completeness, I just want to point out that you also can change your layer system at the for each circuit. So this one is set to new, to the default, and it's pulling the new. We could force it to be new, so no matter what we change the default, it'll show up as new, or we could force it to existing. So I can change it here to existing. And there, since I'm changing just that one circuit, it actually sees it and it updates it for us. So it changes that layer system to existing. So that's the options you have for your layer systems. Those layer systems will also impact the feeders between devices on the one-line diagram. So if I put in the one-line diagram here, that's going to control these feeder lines here. So right now it's set to all be new. I'll go ahead and change it back to the default, or the original default, which is same as distribution equipment. And so these circuits connected to L1 will now change to be existing circuits when I update the one line. So that's how you control those layers. You can change those in the circuiting dialog the same as the other just branch circuit layers. For the one line diagram, you can also use the change layer system command. If you run that and select a feeder, you have the option to then force it to an existing specific layer. That actually changes the setting in here as well. So that changed this circuit to the layer system to new. So it's like you came in here and changed it. It's just a little bit easier to do it from the drawing using this command. The next option that we have is the receptacle circuit count limit. So you can, in general, and actually you can always connect whatever you want and as much as you want to a circuit, but we have an option to give you a warning if you exceed this circuit count. So if you have more than 10 receptacles, it'll throw up a warning. And so you can at least know that, oh, I've maybe overloaded the circuit. Maybe I should split out my receptacles. So let's go ahead and see what that looks like. I'm going to need some more receptacles here. So let's insert a receptacle. So there we go. We got 20 receptacles now. And I can circuit them. Take this circuit. If I circuit just a couple, I take 4 of them. They connect just fine. If I put all of them on that circuit, then it comes up with the warning. It says we've exceeded our limit. On that circuit, we have 10. The limit's 10. You've put 20. However, it does let you connect them. You're still the engineer. You still have the ability to ignore our software and our warnings. So you can click OK. It makes the connection, but you've at least been alerted that maybe this is more than you wanted. But maybe if it was 11, you're like, you know what, 11, I'm going to be okay with that, even though it's kind of exceeding my limit. So we don't force you to use that. It's just a little warning, but it's not binding. Also, in options for our circuit warnings, we have a circuit load limit. Defaults to 0, so basically it's not going to check the load, so you can connect anything you want. This is something that you actually likely would turn on or off as you're working on a project. So you might say, okay, I'm going to do a bunch of lighting circuits, and I don't want to exceed 16 amps on these. So you can set it to 16, load up a bunch of lighting circuits. If you exceed the 16, you get your warning. And then when you're done, put it back to 0 so that when you're doing your motor loads and things that are obviously larger than 16 amps, it just kind of ignores you and just goes along with that. So if I change this here, set that to 16 amps, click OK. And now I'm going to put in, I probably need some light fixtures. If some things are already circuited, it's not going to do anything about that. So in this case, it saw that, it increased this, actually it's 225 amps, so that's clearly way over that 16. But since it was already circuited, it's not going to warn us about it. It's only on newly circuited devices. So we circuit these two, and it says, oh, you've got a 16 amp limit, you've exceeded it. You should know about that. But again, it does the connection. So move those to the new circuit. It still lets you be the engineer and make your choices, but it's giving you a little bit of feedback and warning. So you might want to change it, do your circuiting, and then when you're done, you would change it back to 0, and then it'll stop bothering you. Next option is the option to include room names and circuit descriptions. Defaults to no, and so we'll just give you the circuit description. You can change that to yes, and then we'll include the room name on the circuit with the option to say room and then the room number, or just the room number without saying room. I'll set it to say room. Click OK. For this to work, you actually have to have inserted rooms with our software. So we can't read it off the architectural model or anything like that. You do have to define the rooms with Design Master Electrical. And to do that, you need to use the room command. I can select it, and I can create a room. We'll create room 101. And that actually already exists, because apparently I do have some rooms, they're just not on the drawing. I'll create 201, put it in here. So now 201 actually has some devices in it. So let's go over to L17. And if we update this panel schedule here, L17 should say it's using room 201 there. And it does, so it says lighting or receptacle, puts in a comma, and then the room number. We also have the option to do it without the room number or without the room label, so we could change that, update, and then it'll just say 201. If you have multiple rooms, it will list multiple rooms on the circuit description. So we've got room 201 there. I'll go ahead and put in another room, call this 202, create this room. And so L1, 3, and 5 should now have 202 listed. So we come back over here, update our panel schedule, and you'll see that we list those rooms there. So 201 and 202 both being listed. This does obviously require a little bit of work in terms of setting up the rooms, but once you've set up the rooms, then they're put in the panel schedule automatically for you. So it's a question of what is going to be more or less work for you, putting the labels in yourself or putting in the rooms. The next option is the option to include, to size breakers to 100% of continuous load. So the NEC allows you for your breakers to do it at 125% of continuous load and 100% of non-continuous load. The default for new projects is yes. And we added that a couple years back. The original way we wrote the software was that it was always sizing breakers to 125% of the entire load. So basically we treated everything as continuous. Partly that was easier, and partly for the engineering standards of the company we were closely aligned with during the development, that was their preference. They didn't like to take advantage of this section of the NEC, and they preferred to just slightly oversize their breakers and not try and undersize them for the non-continuous loads. Other customers wanted to do that, so we added this feature. It's more closely matching the NEC, so we do that by default. But if you want to, you can change that from yes to no, and then it'll size the breakers, all of them at 125%. So for an example of that, let's go ahead and first of all, I'm going to get rid of my building tab because I will not need that anymore. And then we'll go into circuiting, and we're going to create a non-continuous circuit. So 5 kVA gives us 41 amps, so we get a 50 amp breaker. 125% of that is going to be 51 amps, and that's actually going to give us a 60 amp breaker if we change the setting. So we'll go back to options, and we'll change that to say, no, don't do 100% of continuous. Basically treat everything as continuous and do it at 125. And we go back to circuiting, and you'll see that it gives us a 60 amp breaker instead of a 50 amp breaker. Next option that we have are the custom load types. So Design Master has an extensive set of load types. We did our best to basically match everything that you could find in NEC 220, 40, and following. And we think we did a pretty good job. But there are times when you want to have a load type that we don't include. People often want to put a computer load as a separate load or something like that. And maybe it's using a demand factor that already exists, but you want to have it called out separately. So we will create one. We'll call it computer. So say we want to track the load of our computers. We can give it a load name. Then we have the calculation method, whether the demand factor is fixed, just like a flat 125 or 100% or 65%. We can also set it to be a variable demand factor, where you set the demand factor at the device level so you can actually change it, or the ability to set the calculated load. So rather than setting a demand factor, you just set the connected and the calculated load, and the demand factor is basically implied based upon that. And then if it is a fixed demand factor, what that value is. So if it's fixed, you enter it here. If it's variable, we disable that, and then you can't actually change it because it's set in the device. Same with the variable calculated. You can't set the demand factor. So I'll do a fixed demand factor. We'll say this is 125. The computers are always on. They never turn them off. And then the load type, whether it is continuous or non-continuous. And this then feeds back into this option here as to whether we size it at 100 or 125% based upon this setting. So we need to know whether to treat it as continuous or non-continuous at the branch circuit level. So we'll leave it like this. So now we have that computer load type. And now when you put in, say, a receptacle, and you're selecting the load type, you now have this new option. Custom 1 is renamed to computer. And so you can specify that this is a computer load. And we'll put in this receptacle here with our computer load on it. And then we can circuit that device. And so now we've got that load. If we do set circuit information, you'll see that down here, the custom load 1 has been renamed to computer, and it has that load. You can also do it as a fixed load, so we can have another kVA of computer load on this. So we can specify the load on the devices or in the circuits, same as any other load type. And then finally, when we update the panel schedule, it's going to show up down here in the bottom. And the computer is now listed 1.5 kVA with the demand factor that we have specified. In our old panel schedules, there's kind of a space where it would show up. With the new dynamic panel schedule footers, it can just nicely be added to the list of load types. So it just kind of gets displayed as all the others. So it works out nicely. That's one other benefit of the custom dynamic footers that we implemented with the last release. So you have two custom load types that has so far sufficed for everybody in terms of how many load types that they need to add, because we have a pretty extensive set otherwise. We'll change this from a fixed to a variable just to see the difference. So if I do that, and then I query this receptacle here, we have the option to set the demand factor. So we could set it to 0.8, and then we'll get a different load at the for the feeder and service calc. We can also, at the circuit information, for the fixed load, we can specify a different demand factor here as well. So you can actually have different demand factors at different points if you want to, and that's the whole purpose of that. And then we run the calculation, and it does the calculation and gives us does the calculation, and it gives you the average demand factor basically across all your devices. Next option is the wire sizing option. And here I don't think I have any choices because I only have one specified in this project. This is actually set more appropriately in the wire sizing setting. So if we go to DM Electrical, Customization, Wire Sizing under Edit Project List, we have the sizing options. I only have one here, so that's why that is the only one that shows up. If I create a new one, call it example 1. Now we actually have two choices, and so we need to know which one's the one that's current. You can actually set that here with this checkbox. You can also set it in the options. The main reason for setting it in the options is that way at the standards level you can set it in the options, so you can have different standards with different defaults set, because this dialog is shared between all your projects and at the master level. So you can set for different standards different defaults. And these sizing options then control which of these columns here are checked for standard branch circuit and standard equipment and feeder sizing. So you could have, say, okay, this is a copper sizing, and then this is an aluminum sizing option, and flip between the two and have it automatically resize using those different materials. The next option is kind of paired together. We've got the show number 10 when wire is upsized, which is really talking about the option below it. So the first option, and this should really be flipped so they make more sense, is the upsize number 12 to number 10 wire length. So when you have a circuit where the farthest device exceeds this distance from the panel, if it's a number 12 wire, we will automatically upsize it to a number 10. So we'll take your number 12s, upsize them to number 10 because they're a certain distance away. So all our calculations will take that into account. And then we have the option for on the home run, whether we want to display that or not. Some people basically handle that in a note in their spec. Any wires over 75 feet, number 12, upsize to number 10. Other people like to show it on the drawing so that it's clear that this one is one of those that has been upsized. So let's take a look at those options here. I'll leave them as they are, upsize after 75 feet, and do not show the label. I'm going to draw this home run here because I'm guessing that this is going to be over 75 feet. Draw the home run. And yeah, if you press F2 and pull up your command line, we actually display the voltage drop when you draw the home run. We don't make a big deal about it, but it is there. So this is 184 feet away from the panel. So it's obviously going to be upsized, though I think, let's check one more thing here. That's L111. Yeah, so that is typically would be a number 12 wire, but it's going to be upsized to number 10. But we have it set to not show it, so it's going to kind of show up everywhere as a number 12, but in the calculations it's actually being calculated as a number 10. So then we can go into our options, and we can say, okay, we actually do want to show that it's upsized. Say yes to that. And if I redraw the home run to give it a chance to update everything, it'll redraw it with that number 10. So say, okay, this is a circuit, and it's using number 10 instead of number 12. It doesn't give you the whole description. It still does the tick marks, but it says this is a number 10 wire. Next option we have, display neutral wire count separately from phase wire count. So this is for your wire callouts. If you're neutral and wire, hot wires, if we list them together or separate. So looking at a circuit, it's listing a number 12 and a number 12 neutral. So those are separately listed. We could combine that and just say two number 12, knowing that one's the hot and one is the neutral. So we can do that, and it gives you a slightly shorter wire call out. So I will do that. Change that to no. So now we're actually going to combine them. Let me take a look at that circuit again. And you see that it lists two number 12, so the neutral is not listed separately. However, if you size the neutral differently from the phase wires, we obviously still have to call that out. So if we come here and we say, okay, I actually want a number 10 neutral, it has to ignore that setting, say it's a number 12 and then a number 10 neutral, because you can't combine them because they're different sizes. So if required, it will separate them. But then if you go back to put them the same size, it'll list them together again. The next option that we have, on the wire callout, whether the conduit size is at the beginning or at the end. So we've been looking at it at the beginning, so it's a 1/2-inch conduit and then the wire size. We can also do wire size and then 1/2-inch conduit at the end. So if I change this to end of wire callout, when you do that, it takes a moment and actually updates everything. So it does kind of have to go through the database and make some changes. But we pull up this circuit, and now it's two number 12 ground, 1/2-inch conduit, rather than starting with 1/2-inch conduit at the beginning. No real difference in anything that's happening other than the output, because different people have different preferences on how they like to label their feeders and branch circuit sizes. And then the final option is the option to size utility and transformer grounds as service grounds based upon NEC 250-102. So generally you would want this set to yes, because 250-102 is for a separately derived service. How to size those grounds is a little different from an equipment ground, which is 250-122. And so you want to have them sized differently. And so our software does that. So when you connect something to the utility, basically it's not connected to anything. We assume that's the utility, and we size that ground as a service ground. If it's connected to a transformer, we again use the service ground sizing for that. You can override this at this level, at the options level, and say, okay, I want all of my grounds sized using the equipment ground. And then I'll specifically call out the ones myself that I think should use the service ground sizing. So you can change that to no, and then any feeder that's connected to a transformer is going to use an equipment ground unless you change it. So to really see that, you have to look at the feeder sizes. So L1 is being fed from a transformer, so its ground is a number 4 ground. It's actually, so if it's set to size automatically, it's now going to size as an equipment ground. But if we change that back to yes, it would size it as a service ground. And I'm not sure if those are different at this size. So an equipment ground is a number 4, a service ground is a number 2. So you'll see that it's actually using the equipment ground. So if I go back to size automatically for it, it's going to stay at the equipment grounding size. But then if I go back to options and set that option back, it'll change it to a number 2 ground. Go to that panel, and it's now using a number 2. So the ground, when it's sized automatically, since it's connected to a transformer, is sizing based upon the supply side bonding jumper. Which means that if you have a feeder to a panel, that ground size will change as you connect it to different things. So the feeder size is going to vary a little bit depending on what you're connecting it to, which is generally what you want. And since we're here, this is all, that option controls the size automatically. You always have the option to override it and say, for this piece of equipment, I always want an equipment ground, I always want a service ground, or I just want a specific wire size. And you can tell us what size ground that should be. So you can always override it there. That is the final option in that section. Thank you for watching today's Design Master training. Contact us with questions or comments by calling 866-516-9497 or emailing support@designmaster.biz.